Question number 1 says, which fractions are greater than 3/6? Circle the letter for all that apply. There are some key words that your child should pick up on. All means that there's more than one correct answer, and having an S here helps them know there's going to be more than one answer. So in order to solve this problem, they need to pay attention to the numerator and the denominator. We've been learning in class that if the numerators are the same, that the denominator will help us know which one is greater. If the denominators are the same, we're going to be looking at the numerator. So let's focus on A. We see that 6 and 6, the denominators are the same. So since this has 3 pieces and this has 2 pieces, we know that this is greater. So we're not going to pick A. And I've been teaching the students to put the X on the ones that are incorrect here, because the math coach told us that if they exit here, that on the FSA they might count that as answering the question instead of saying that that answer's wrong. So let's look at the next one. We notice that the denominator is the same. Looking at the numerator, we can say that we have 5 pieces, which is greater than 3. So B is one of the correct answers. Looking at this question, we can see that the numerators are the same. And I keep on telling the students that the bigger the number, the smaller the piece. So since this has a bigger number, this is going to have smaller pieces than this. These pieces are going to be larger. So if you have 3 larger pieces, 3 smaller pieces, this will be greater. That is another correct answer. If we look over here, we can see that the denominators are the same. So if you look at the numerators, 8 pieces and compared to 3 pieces, the 8 is going to be larger because the pieces are the same size. So D is another correct answer. And the final one, we see that these are the top number, the numerator is the same. So the denominator, these pieces are going to be smaller because 8 is larger than 6. So since these are smaller, this is going to be greater. So E is not a correct answer. Part A, draw marks on the number line to show 8s. We're going to circle 8s because that's a key word. Above each mark after 0, write the fraction it represents using 8s for the denominator, also a key word. So our number line has it broken up into 4s. There are 4 equal parts. So in order to make it 8s, we need to take these parts and break them in 2. Now we have 1, 2, 3, 4, 5, 6, 7, 8 parts of the one whole. So I'm going to label my numbers on the top. So we know that there's 8 parts. So for all of these, my denominator is going to be 8. The numerator is how many jumps you make on the number line. So, or how many parts of the whole. So this would be 1 part, 2 parts, 3 parts, 4 parts, 5, 6, 7, and 8. So now let's answer these questions based off of what we've done above. Which fraction on the number line is equivalent to 1/4? When we practice in class, I said put a box around the bottom part and the top part, and that will let you know where they're at, where they're the same. So 1/4 and 2/8 are equivalent. equivalent meaning equal. Which fraction on the number line is equivalent to 2/4? So we find 2/4, put a box around that and the fraction where it matches up, and 4/8 would be equivalent. Which fraction on the number line is equivalent to 1? So right here, 8 out of 8 is the same as having 1 whole. This question says, fill in each box above the number line. Use the fraction below to name these points. Not all the fractions will be used. So this number line has 2 holes. So we're going to find what the fraction would be within the first hole. So from 0 to 1, we have 1, 2, 3 parts. There are 3 parts of the whole. So since between 0 and 1 there are 3 parts, between 1 and 2 there are 3 parts, our wholes are broken up into 3 parts. Our denominator will always be 3 for this problem. So this would be 1/3. This missing spot would be 2/3. So that is represented right there. Then we have the whole, which would also be the same as having 3/3. And our next spot would be, the denominator would still be 3, but our numerator would be how many jumps to this point, which would be 1, 2, 3, 4 jumps. This right here would be 5 out of the 3. And then here, if you jump from here all the way to here, it would be 1, 2, 3, 4, 5, 6 jumps out of the 3 segments of the whole. If you were to draw a picture of what this would look like, if you didn't want to do it in a number line and you want to draw a picture, this would be having like 2 circles, 2 holes, 1 and 2. The circles are broken up into 3 equal pieces. Kind of looks like a peace sign. This section right here would be 1/3. These sections would be 2/3. All of these sections would be 3/3 or 1 whole. This is 1 whole piece. This would be 4/3. So let me fill it in. 1/3, 2/3, 3/3, 4/3, 5/3, 6/3. That's what it would look like using a picture. It's the same idea, except it's going straight across instead of filling in circles. So in this section, we're going to be comparing fractions. If it has the same numerator, we're going to look at the denominator to see. The larger the number, the smaller the piece. The smaller the number, the bigger the piece. So in this scenario, this has smaller pieces because there's more segments you would have, and this has larger pieces. So this is how the greater than sign would work, because as we tell the students, the alligator eats the larger number. If you want to represent that with a picture, you could do 2 rectangles, one broken up into 8ths, one broken up into 6ths, both having 3 sections colored in. As you can see, this is greater. Here, both the denominator and the numerator are different. So drawing a picture would be helpful in solving this. When you draw your pictures, they have to be the same size and the same shape in order to compare for the fractions. So this shape is going to be broken up into fourths, and this shape is going to be broken up into a half. This shape is going to have 2 out of the 4 colored in, and this shape is going to have 1 out of the 2. As you can see, both amounts, the same amount is shaded in, so that would make it equal. This is the same as having 1/2. Here, the numerators are the same, so we pay attention to the denominators. And since this is a bigger number, we know the pieces are going to be smaller. So this has to be greater because it's 4 larger pieces. Here, we know that the denominator is the same. So it'd be like 2 rectangles. So I was doing a video explaining this, and then all of a sudden the video just stopped. So I'm not sure what happened. So I'm going to go back and re-explain what I did. So when we compare fractions, it's important to figure out if the numerator or the denominators are the same. In this problem, the numerators are the same. So that means the pieces we're comparing are going to be different sizes. The larger the number, the smaller the piece. And as you can see in this picture, these pieces are smaller than these pieces. Here, when you color in 3, you don't have as much filled in as when you color in 3 on this shape. This would be half of the rectangle, and this would be missing part of it. So that makes 3 out of 6 greater than 3 out of 8. Here, if you draw a rectangle, 2 rectangles, and you partition this into 4 pieces, and you partition this into half, you color in 2, you color in 1. As you can see, the same amount of the shape is colored in. So that makes 2/4 and 1/2 equal. Here, if we draw 2 shapes, we partition this into sixths. And partition is just a math term saying you're splitting it into sections. They call it partitioning. And you partition this into fourths. You can see that 2 out of this shape and 2 out of this shape, that this shape has a greater amount shaded in. So for D, we're going to go ahead and partition both shapes into thirds. And since the denominator is the same, the numerator tells us how much is shaded in. So 3 out of the 3 would be the whole shape. This has 2 out of the 3. So 3 out of 3 is the greater fraction. So this question says, which fractions are equivalent to 3? Circle all. Keyword all right here, meaning that there will be more than one answer. So here, 3/1. What this looks like in a fraction is if I have 3 circles and it's in one piece, it's not partitioned at all. It's one piece. There's one piece, one piece, one piece. If I were to fill in the 3 out of the 1 pieces, it would give me 3. See, 3 circles. Here, if I had 3, so this is 3/3. That means that I have 1 circle in 3 parts, and 3 of the pieces are shaded in. This, oh, I forgot to circle A because that equals 3. See, 3 circles, 3 holes. 3 over 3, this doesn't equal 3 circles. This equals 1 hole. 3 out of 3 is equal to having 1. And that's why this answer is not correct. Here, if I had circles that were cut into 2. So we're going to use this picture again. And I need to have 6 pieces. 6 pieces that are in 2s. So 1, 2, 3, 4, 5, 6. If you put halves together, 6 halves together, you get 3 holes. So this one also is correct. Let's try it with fourths. So we're going to see if I take this shape and put it into fourths, if I would have 12 pieces all together. So let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This fraction also works because if I put 12 fourths together, it turns out to be 3 whole circles. And this one, putting it into eighths. So I'm just going to cut this here, partition it like that. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and let's see, do I have 18 all together? Let's count it. Now, this is a little bit more confusing because there's so many shapes here. So what I like to do to make sure I count correctly is I might put like a little line here, or you could put like a dot, just so you know when you count it that you're not counting it more than once. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So there's actually 24 pieces out of the 8 if I was going to make 3. So this one is incorrect. These would be the ones that are correct. Now, if you have a different way of doing this, as long as you understand how to make holes, I'm just worried about the end result. So if you're teaching your child to use maybe multiplication or division in order to solve this, and the visuals are confusing to them, and you have another way that works, I'm completely fine with that. We're not worried about this as much as the end result and that their strategy makes sense. This problem says Pam has 3/4 of a cereal bar. Jody has 7/8 of a cereal bar. We're going to go ahead and circle the numbers because that is a strategy when we do word problems to help draw our attention to it. Show the number of equal. Equal is a key word because we know it means it has to be the same size or the same shape and the same shape. Show the number of equal parts in the model of each cereal ball below. Then shade each model to show the fraction of a cereal bar in each girl has. So here, I know I have to cut this into fourths. I'm going to partition it across and then partition it like that. That's my fourths. Now I'm going to start it off like fourths, where I partition it across, partition it down, 4 equal parts, and then I'm going to do a dividing line here because I know this will give me 4, and if I do it again here, this will give me 4 again. So on this side, I need to shade in 3 of them. 1, 2, 3. On this side, we're going to shade in 7. 1, 2, 3, 4, 5, 6, and 7. In this problem, we can see that Jody has more than Pam because there's only one piece left over in both, but this piece is much larger than that piece. So that's all that question was. So these type of problems, equivalent fractions on number lines, is where a lot of students have really shown a lot of struggle. So we're going to look at this closely, and I'm going to show you some things you can do to help your child understand it. So we have 3 different examples. The first step would be to see what is the fraction for Q. Look at point Q on the number line. Does the point on each number line below show a fraction equivalent to the fraction shown by point Q? Circle yes or no for each number line. So here, we need to figure out what this fraction would be. Well, to find out our numerator, it's how many jumps to our point. 1, 2, 3, 4. 4 jumps. To find out our denominator, it's how many jumps are in between 0 and 1. So 1, 2, 3, 4, 5, 6, 7, 8. Now from here, you can go ahead and find out the fractions here, and if they want to draw pictures to represent it, they can, and just match it up. So here, it's 1 jump to our point, and from 0 to 1 we have 1, 2, 3, which would be our denominator. Here to our point is 1, 2. So our numerator is 2, and our denominator is 1, 2, 3, 4. And for the last one, we have 1, 2, 3 jumps to our point, and 1, 2, 3, 4, 5, 6. So having the fractions written out might help a little bit in understanding equivalent fractions. Another thing you can do is, if it's hard to figure out how it matches up between the number lines, draw a picture. So for here, draw a rectangle, and put it into. In the last clip, it cut off short, so I'm going to go back and explain the pictures. So if you look at the fraction that goes with the number line, if you draw in a picture form, this would be 4 out of the 8 pieces. And as you can see looking at the picture, that's half of the entire rectangle. So this half is not colored, this half is colored. When you look down here at the other fractions that go along with the fractions over here, you can see easily that this is half and this is also half. So that is why this is a yes, and this is not half. That's why this is a no. Encourage your child to color in the same direction. Like if I were to color this box and this box, it would have been harder to see half comparing it to this shape. So if they color it across here, have them continue to color across here. Another strategy that you can do is see if this is in thirds, could you make 3 equal groups? If this is in fourths, could you make 4 equal groups? If this is in sixths, could you make 6 equal groups to try to compare? That strategy works sometimes it doesn't. I think drawing pictures might be the easiest way to compare fractions, because sometimes it gets confusing on the number line.